Okay, we're rolling. This is the second part of a two-part series. It could be three-part. Talking about the red shift, where the various metals and ceramics and carbon rod, like this one. This is a carbon rod that I've been using. It's a brand new one. I haven't used it yet. Where you put it into a pipe to use it like a temperature gauge to actually see or to measure what's the temperature that's happening within the vortexing of the level 3 flame, right? And going back a couple of years, about 3 years now, when I was over at Gabriel Island, Tina, if you're watching this, you'll remember, because I was actually at your place when I was doing this. This was the second test using a piece of titanium at a titanium stock like that, 1 inch, a little bigger than 1 inch, maybe 7 inches long. And it was just getting dark, and it was about this time of the year where we're going from summer into fall. And I was over at my friend's place, and I thought, well, we better hurry up because, you know, getting dark. The stuff was, because at the time that, you know, I found out then that the change in weather, or where it gets cooler, can actually have an effect on the operation of the flame pipe, but there is a way to compensate it. It's actually the change in the pressure. The colder it gets, it changes the pressure, or affects the pressure. Anyway, had this test set up, and where we had a piece of porcelain inserted into the titanium, and inside the porcelain tubing it had this rod like this, right? And so there's a little bit of a gap here, air gap, not much. When we lit the end, it started up all right, and then it went back in behind here. There's about maybe a space of maybe under an inch, maybe more considering the cap here. So there might be an 1.5 inch gap. And everything went well for a few minutes, and all of a sudden, this copper cap here turned bright red. The propane in the air was actually being fed in, and I was using a 12-volt air pump, tire pump, to actually bubble, or not bubble, to pressurize the system. And I had the propane just teed into the airline. And anyway, this cap started going funny. I mean, it just went hot. And I've never seen it do that, except in the first test using titanium. The titanium itself went hot. The copper didn't change color. The copper did not go superconductive. The titanium went superconductive. It passed actually up into the melting point without actually melting. So there is a sublimation of states that can take place. I've seen it, you know, what can I say, right? And anyway, in this test, the copper cap went translucent, and it wanted to fall out just under its own weight. So I remember I grabbed the red pair of pliers, and I grabbed onto it. That's how I can say, well, it wasn't melting. It was still remaining in a solid form. And as I was pulling back this cap, it actually began to push back the titanium. The titanium became like sludge. I could took it like this. I was able to move it. It wasn't a problem. And we know that, you know, copper melts just under 2,000, and titanium takes another 1,200 degrees. So what's going on here? And it was just getting dark, and when we pulled back the cap there, I seen that the propane was arcing. I had it pulled back maybe a couple inches. It was actually arcing back into this hot spot. You couldn't tell the difference between the carbon rod and the ceramic tube, or the porcelain tube. You couldn't tell. It was just one big red, very, very bright red, maybe a little bit of orange. So, and you know, looking back, I can see that it was at the, probably around 1700 degrees, maybe 1800 degrees, somewhere around there. And but because it was kind of confined to the back of the pipe, maybe it produced some kind of fireball. There was one time that I had seen a purple fireball that actually vaporized fire brick, turned fire brick into the vapor state, then recondensed it back into glass. So we're talking past the melting point of that particular fire brick. But anyway, we saw this, the propane, wasn't on fire, just all these bands of energy, all these colors. And it was actually going in and turning this hot. It was just like one big plasma torch, but it was more than white. It had all these different, the entire frequency band of the rainbow. And so that's what I'm talking about when I'm saying hot point, and like a hot point reaction. And is it possible to take the joule pipe, and by taking a handful of these carbon rods, cutting them up to about 1/3 or to about 4 inches long, and take the 1.5 inch titanium tubing and pack it into the end, and maybe just push it ahead to leave a little bit of a gap, like inside the titanium pipe, and then take the fire pipe, the joule pipe, fire it up on a horizontal test, and already crank it, right? And leave it warm up for a few minutes so it gets red, and then insert the titanium pipe with the carbon rods right to the back. And so the fire is actually going to jump into the titanium rod, and it's going to be interesting. But what can we expect in something like this? Well, is it going to raise the temperature of the titanium? Is the titanium going to go into the yellow state, or maybe even become white hot? Is the heat going to trigger a quantum reaction where the propane is converted into the plasma state? And so this is something that needs to be checked out. But we're getting close to understanding the internal operations, and I think I may do a third part of this to show you, as far as what I've come to understand over these years, what actually is happening, what kind of reaction is happening between in the third state of matter and in the fourth state. Thank you.